So for the next video, we'll be using the same equations and talking about 2D kinematics again. As you can see, those are our equations up there. Specifically, we'll be talking about the using derivatives and integrals and the relationship between velocity, acceleration, and position or displacement. So we'll get right into it. The derivative of position or displacement is velocity, and the derivative of velocity is acceleration. So that means the integral of acceleration is velocity, and the integral of velocity is x position, or not x position, but displacement. So that can be very useful, say if you're given an equation like velocity equals 5x plus 10. So now if someone wanted you to take the derivative of that, all you would have to do, if someone asked you to find the acceleration, all you'd have to do is, find the derivative of this equation, which is a t equals 5. But if someone wanted you could also find the equation for the position or displacement. So you can do this by taking the integral of this equation. So to do that, all you have to do is integral of 5x plus 10, and you can find that would equal 5 over 2 x squared plus 10x, and then plus c. Remember, when you do integrals, you always put plus c, and what that would mean in this context was say we're talking about projectile motion and something's being fired. The plus c would be, say it's being fired above ground level. It would be, c amount of units above ground level, or c amount of units below ground level if c was negative. So now that you guys know that, we'll go to problem number 16. I'll read it real quick. A ball of mass 2.0 kilograms is thrown vertically upward from the top of a building. The ball's velocity, v, is given as a function of time, t, by the equation vt equals r minus st, where r equals 5 meters per second and s equals 10 meters per second squared. The positive direction is upward. So you can get a little look at that. And now the specific question within this set is, if the ball reaches the ground at t equals 2 seconds, what is the height of the building, right? So what we know, let's write down what we know. What we know is the equation v, so velocity. So velocity equals r minus st, and we can simplify that because we have the values of r and s. So we have that. So that equals 10. I think it's 10. Oh, no, my bad. 5 minus 10t. Now what we're going to need to do is find the equation for the x position. The y position. So how we're going to do that is use the equation and find the integral. So we're going to find the integral of 5 minus 10t. So if we do that, dt equals, we'll come up with 5t, of course, minus, and then the integral of negative 10t minus 5t squared, and then plus c. So that plus c is going to be what we're going to need to find, which is the height of the building. So now we can use this equation, and we know that at time 2 seconds the ball hits the ground, right? So we can say and the height of the ground is 0. So we can say 0 equals 5 times 2, because we know that's when height equals 0, minus 5 times 2 squared plus c. So now all we need to do is find the value of c that'll make this equation 0. So what we're going to do, simplify it. 0 equals 10 minus 20, and then plus c. So now we can obviously see that c, which is the height of the building, should equal 10. And that is the height of the building. Now we can see, if we go over here, look for the answer option 10 meters. And we see that is answer choice letter B. And we can circle that, and we're done.